Well, good morning, good crew. I am homesick again today. I think this is the first time I've missed 2 days in a row in a long time. But anyway, I'm still not feeling very great. So I'm going to go ahead and do a video lesson and then let you work. Hopefully I'll be back tomorrow. I guess that won't matter for you guys in English, so it'll be about the same. But today we're going to work on transformations of functions. And when we talk about, there's a common functions that you do really need to kind of have a grasp on. Constant functions, again, are going to be always horizontal. Remember, the vertical ones are not really functions, and that's why they don't even represent them. And then all functions can be represented as x. Our identity function, is when the x value is going to equal the y value. There are also then absolute value functions. There's also quadratic functions, square root functions, cubic functions, and then cubic root functions. And it's just the same. This one is probably the one that's probably a little less you're less familiar with, but it's usually just going to be the turn rotation on the cube from the standard. So let's just jump in. Now, when we talk about shifts, either horizontal or vertical shifts, if the constant is outside of your function, so if you have a function and then plus c, then that means it's going to shift up and down either. In this case, this is going to show that you have a function, and if I have just this line from -2 to 2, and it's going to be f of x then plus 4, then my new function will look like just going 4 up. So 1, 2, 3, 4, and every point then will shift 4 up. If I have then the f of x equals a -3, so it means you're going to go shift down. So 1, 2, 3, 4, and then you'll have a line that change. So again, my blue function is going to be h of x, and my red function will be then g of x. When you have a function within the function, that's when you change it from left to right. But a lot of your problems are going to look like similar to this. It says use the transformations of an absolute value function to graph the g of x equals absolute value -7. And so what transformation is needed? So this is kind of what you'll see on your homework when you start to do the graphs. And so in this case, if I'm going to just go -7, that means you know that that's going to be then a horizontal. It's not going to be a shrink. It's just going to be a horizontal shift, or vertical shift, sorry. Horizontal would be left and right. Vertical would be up and down. Now, if I'm going to go ahead and do horizontal shifts, that's when the function is within the change is within the function. So it's like when you remember, it'll always also look like it's doing the opposite amount. So if I have a f of x plus c, then it's actually going to go and it'll be a shift then to the left. If it is x minus c, then it's going to be a shift to the right. So if I look at, say, the function that I'm given here. So I have g of x. So f of x is graphed. And so I have all of these points. And if I have just f of x minus 4, what that's saying is that I'm going to go to the left 4 units. So my x value, if I have the point -4, 0, and I go to the left 4, that means this point will be then 1, 2, 3, 4. It'll change then to -8, 0. If I then could do that the way all the way through. So in this one is -2, 2. And if I come over to the left 4, that would be then just then -6, 0, etc. Now, if I see that I have the f of x is x minus 3, that means I'm going to go to the right 3. And so in this case, my point of -4, 0, since I'm going to the right, will now change then to -1, 0. And then my other point, -2, 2, will change then to 1, 0. So again, when you look at this problem here, I'm going to look for a transformation of to the right. So it's going to be a horizontal shift. Let's see, to the left. There it is. To the left, not right, because that would be an x minus 3. X minus 3 would show me to the right, and it's not going to be upwards. So it won't be upwards, and it's not going to shift downwards. Reflection about the x-axis is when the negative is out in front of your function. Reflection about the y-axis is when it's within. So if I look at this function here, and I say, okay, what is happening here if I have g of negative of f of x? So if on this case, notice that my x values are going to stay the same, but my y values are going to be opposite. So if I have the point negative 2, comma 0, negative 2, comma 0, x are going to stay the same, so it's going to be a negative 2, comma, and then the opposite of 0 would still be then just 0. Then the next one, when you have 0, comma negative 2, or 0, comma positive 2, you're going to end up with the 0, comma, and then the y values are going to be the opposite, so it's going to be minus 2. And then I would want to do one more, say 2, comma 4. And again, it's going to change. The x values will stay, so it's 2, but then the y value will be negative 4. On the next one, h of x, when I I do that one, what will happen is the y value will stay the same, and the x values are going to be the opposite. So when I have the negative 2, comma 0, like I had before, that's going to change then to 2, comma 0. When I have 0, comma negative 2, or 0, comma 2, that's a positive 2 to start with, then I know that I'm going to end up being the same point. So 0, comma 2. And then the last one, when I have 2, comma 4, that means my y values will stay, so it's going to be, but my x values will be negative, so it's a negative 2, comma 4. When I look at the transformation of the graph here, since my function was within the function, that means it's going to be similar to here. It's about the y-axis. So if it's about the y-axis, then it's going to look like it's the opposite of what you have. So it'll be this function. I should maybe put that one in red. When we talk about shrinks and stretches, so on this one, a vertical shrink, when you have the function g of x is going to equal 1/3 times f of x. So if this is my f of x, then it's a vertical shrink. You will multiply then the y values by 1/3, but the x values will stay. So by creating the points, again, I'm going to start off with negative 3, comma 3. And then what it'll end up being is I'm going to multiply. The x values will stay, but then I'm going to multiply by times 1, times 1. So I'll have negative 3, and then I'll have comma 3 times 1/3, which is just going to be 1. My next point would be then 0, comma 3. Remember, my x value will stay, so it's 0, and then I'll have 3 times 1/3, and so the other point would be 0, comma 1. And then the last one would be the same thing. It's just going to be, so when you look at that, it's going to look, you're going to have negative 3, 1, 2, 3, and then you're going to come up just 1. So it's going to be a shift here, here, and here. Horizontal stretches are when the function is within, or the number is within the function. So in this case, this is going to be where it's going to be a horizontal stretch. You will actually just divide your x values by 1/2 because you're within the function. So if I have the point 0 or negative 4, comma 0, then I'm going to find out negative 4 divided by 1/2. Now remember, when you divide by 1/2, it's like multiplying times 2. So that's going to change that to negative 8, comma 0. the next one, if I go ahead and go -2 divided by 1/2, commas 4, which is this point right here, that means I'm going to flip this over. That means I'm going to end up with a -4, 4. Well, 0, 0 is just going to stay the same as 0, 0, because when I divide it by 2, it's still going to be 0. But then the next one will change. So I have 2 over 1/2, comma -4. That one is going to equal then 4, comma -4. And then my last one will look a lot like my first one, except with a negative. So it's going to be an arrow, a 0. Plot those, then you'll end up with -8, comma 0. You have -4, comma 4, 0, comma 0, and then 4, comma -4, and then 8, comma 0. So what it'll do is it just stretches that whole function out. Now, obviously, if I had a whole number here, what it would do is it would shrink it. When I look at the order of transformations, to perform them, start off with your horizontal, do your shrinking and stretching, do the reflecting, and then your vertical shifting. So in the first one, it looks like on this one, if I'm going to do g of x, I'm going to look at the x minus 2. That means your x values will shift 2 to the right because it's a -2. Then, because I have the -2 here, it's also going to shift 2 down. So every one of my points are going to go 2 to the right and then 2 down. So I'll put that there. I'll go 2 to the right, 2 down, 2 to the right, 2 down, 2 to the right, 2 down. So that's where it starts to change just a little bit. 2 to the right, 2 down, and then we look like that. So the next one, if I look at the x, the negative x, remember that's a reflection about my y-axis. That's also going to be then a shift going up. So I'm going to go flipping it over my y-axis, and then I'm going to come up. So I will be, because my parent function will look a little bit like this. So I flip it and then shift it up. So then my function for h of x will look more like this. Again, some of the problems that you will have are identifying, what you're doing with the graph. So when you do this, look inside the x inside. This is going to tell me left and right. Since it's plus, that means you're going to go ahead and do a left. Since it's +1, that means, or +3, sorry, you're going to go up 3. And then this is going to tell you the shrink or shift. So let's go ahead and when you identify, and it's also a reflection about the y-axis because it's a negative. And then to graph it. So horizontal, I'm going to go left. This one's right, so I know it's not B. It's right, it's not that one. I go left 1, vertical factor of 2. Reflected about the x-axis, and then a shift up by 3. So this is the one that will actually work. So then I would go ahead and just mark that. So left 1, up 3, 1, 2, 3, and then it goes down. All of these can also be done by just plotting them on Desmos. And so on this one, I will kind of allow you to, that would be a good tool if you get stuck on one at your homework. Nice.